All right, well, I will kind of go ahead and get started, and Katie can let in anybody else that comes in a little later. We do have a ton of information to cover today. So we had a great discussion started with Tristan and Jody on Tuesday about safety culture and those soft skills that we need when we are doing our job as safety professionals here on campus in the labs. I am Val Freeman. I'll go ahead and go to our introductory page here. I am the chemical hygiene officer here at Oklahoma State University. I've been working here in EHS for about 3 years. Before that, I was doing about 12 years, a little bit more in medical research. And so I was behind the benchtop for all those years before I came over to the dark side, I guess you could say. So that's a little bit about me. I'll let Shanda introduce herself as well real quick.
Hi, I'm Shanda Judge. I've been with the department for a little over 1 year. I have a colorful background. I worked under PIs and alongside PIs in various types of laboratories, and actually used to work for this department part-time, and then when a full-time position came open, I was like, yes. So yeah, I think that gives Val and myself different perspectives when going into spaces and communicating with different PIs, and those soft skills are so important. So yeah.
All right. So like I said, we've got a ton of information to cover. Before we were talking a lot and sharing experiences, and in this one, it's just going to be a lot of information, because honestly, what we are trying to do here is, let's see if I can get it very quick. We are trying to be able to sharpen that skill of hazard identification. And as trained safety personnel, we would like to be able to know everything. Of course, like Jody had said on Tuesday, we don't always have all those answers, but I'd like to be able to help add some resources to your tool belt so that you can be able to look things up if you don't have those answers, or have a place to go to ask someone else for help. So as we get started here, obviously all of us are, or at least through CSHEMA, we're coming from that higher education background. So we are dealing with a very large scope of research. So identifying those workplace hazards can be a considerable task, because we are dealing with research that can be ranging from that common cancer research and disease research all the way to engineering research, where they're testing tensile strength of steel and concrete, or even that behavioral black bear research where they're putting out hair traps and trying to get follicles to do DNA to follow those populations. So it seems like on a research, they are constantly inventing new ways to try and hurt themselves. So we try and stay ahead of that game, because we're always trying to stay proactive rather than reactive, because we want to prevent that accident from happening rather than going in and investigating after an accident has already occurred. So what are we going to cover? Well, first we're going to cover a whole lot of information. So we're going to start looking at those OSHA standards that are relevant for those laboratory spaces. We're going to cover the documentation that those standards ask all those laboratories to have. So what are we going to be looking for? We're going to be looking for signage and labeling as well. So we're going to talk a little bit about that. Also, that training documentation that everybody seems to forget to have. So we'll talk a little bit about what we're going to be looking for. And we're also going to talk about other sources of information that are going to be helpful for you as a laboratory safety professional, as well as those laboratory personnel. Once we finish that, we're going to transition into the actual types of hazards that we're going to see in those laboratories. So I'm going to cover just the common things that you're going to be looking for or going to be seeing in those research laboratories on campus. Once we've touched on quite a few of those hazards, we're going to move over, if we have enough time, hopefully we will be able to cover some risk assessment. Of course, this could be a huge topic, a course of itself, but we're just going to cover just some common methods of risk assessment, as well as those basics of performing, just those commonalities between all of those assessments, as well as a few ways to make it more effective. So let's jump right in. We're going to start with those OSHA standards. So back through the 80s, all those laboratories were under the hazard communication standard. So that's 29 CFR 1910-1200 is requiring all employers to provide information and training to their employees about the hazardous chemicals to which they're exposed at the time that they start their job, as well as anytime there's a new hazard added to their work area. A lot of us know this as the right to know, which is now the right to understand. The standard makes sure to ensure that hazards of chemicals in the workplace are evaluated and communicated to their employers and employees. Of course, I always say that it's not just the general communication, but you need to make sure that they understand all those hazards that they're going to be exposed to and how to protect themselves. The standard requires a written program, so that wonderful HAZCOM program that we're going to be looking for. And it also requires initial training and additional training anytime a new hazard is introduced. This was adopted in '83 for use in manufacturing. In '87, it was expanded to cover any employee potentially exposed to a hazardous chemical. And it was also revised in 2012 when it aligned with the UN's GHS, that globally harmonized system of labeling classification. So that made all those SDSs that are uniform across the board, as well as labeling. So then in 1990, OSHA realized the need for a lab-specific standard for chemical safety. So we've got the 29 CFR 1910-1450, the laboratory standard that covers laboratories where chemical manipulation involves small amounts of limited variety of chemicals. I should put quotes around the limited. This standard applies to all hazardous chemicals meeting the definition of laboratory use and having the potential for a worker exposure. All these quotes here I'm getting from the OSHA fact sheet. Now, this particular standard supersedes that HAZCOM standard for labs that meet that laboratory standard definition for laboratory use, and laboratory scale. So what are those? A laboratory is going to be a facility where relatively small quantities of hazardous chemicals are used and not produced. A laboratory scale is work with substances in which those containers used for reactions, transfers, and other handling are easily handled by one person. So any laboratory that we see on campus that is storing hazardous chemicals is going to be under this standard. We have lots of other labs here that don't have any chemicals at all. So for those are going to be still under that hazard communication standard, but not necessarily the laboratory standard. And again, this one also requires a written program. That's going to be your chemical hygiene plan, which we'll talk about later. And it also requires that initial training and any additional training when there's any changes. So there's, like I said before, there are exemptions to those labs that don't actually have an exposure to a hazardous chemical, as well as some of those quality control labs that are usually conjoined with those manufacturing and production. So some other standards that are commonly seen in those laboratories, those are going to be something like your bloodborne pathogen standard, the 1910-1030. Anytime there's an exposure, occupational exposure to blood or other potentially infectious materials. This, of course, requires annual training, as well as lots of other documents where vaccinations and exposure control plan is going to be required. And of course, all of that, we're not going to go into detail because there's plenty of information right in there if you look at those standards. The personal protective equipment standard is also going to be seen in your laboratories. There's plenty of dangers that are going to require it. Your respiratory protection standard, 1910-134, as well as your hand protection. I also stuck in here that there's also substance-specific standards under 1910 subpart Z. And I just mentioned a couple of off the top of my head, the formaldehyde and benzene, but there's plenty of others like asbestos. We have an office that is dedicated to that, as well as lead and cadmium. Of course, I also should mention that the respiratory protection standard also requires that we establish a respiratory protection program anytime that we have employees that are exposed to any sort of airborne contaminants. So like I said before, these standards all require a written program. So what kind of documents are we going to be looking for when we go into these spaces? So obviously, we're going to be looking for that chemical hygiene plan. We're going to be looking for those safety data sheets, the SDSs. Something I also wanted to put in here that a lot of people aren't aware of is the laboratory chemical safety summaries, the LCSSs. I'll go into that in a little bit more detail later. We're also going to be looking for, again, that labeling system, right? That globally harmonized system of classification and labeling of chemicals. And we're going to be looking for that training documentation. Don't forget to document your training. So let's talk a little bit more about that chemical hygiene plan that's required from your laboratory standard. This is going to be your lab's written program that addresses all aspects of the laboratory standard. That OSHA fact sheet says that a CHP must address virtually every aspect of the procurement, storage, handling, and disposal of chemicals in the use in a facility. So what are we going to be looking for other than the standard itself? And we're going to be looking for the chemical inventory list, an up-to-date list of all those hazardous chemicals in the laboratory. We're going to be looking for all of those SDSs. We're also going to be looking for the standard operating procedures, those SOPs. So we're going to be looking for something that's going to describe step by step all their processes, all their experiments that they're performing in that laboratory that are hazardous. We're also going to be looking for a designated CHO, a chemical hygiene officer, in their chemical hygiene plan. That's usually going to be your principal investigator. I would hope so. Hopefully it's not going to be one of those grad students that is shuffling in and out. It really should be that original principal investigator who is responsible for that space. We're also going to want to make sure that they are reviewing and updating their written plan at least annually. So a little bit more about those safety data sheets. The hazard communication standard requires that all the chemical manufacturers, distributors, and importers provide those SDSs for each hazardous chemical to the user to communicate information on the hazards of that chemical. These are formally known as the MSDSs, material safety data sheets. Once they were unified under GHS, they all have now in the SDS these 16 sections. They're all going to have the same order in these 16 sections. The first 8 are just going to be general information. The 9 through 11 and 16 are going to be technical and scientific information. And sections 12 through 15 consistent with GHS, but not necessarily enforced by OSHA, because they're usually like in section 12, they're going to be ecological information. And 13, disposal considerations. That's going to be your local municipalities that are really going to be your final say and wouldn't be regulated by a national organization. So I threw in a quick sample. Of course, you know, like everything's toxic, right? So I threw in water, because even that is going to have an SDS. So anytime anybody gives you an excuse that something doesn't have an SDS, you know it's not true. Just as you can go through really quickly, those little sections here, there is, like I said before, Those first 8 sections are going to be the basic identification, general information about that chemical. So first, identification of that chemical. Second, your hazard identification. That's where I look to, where I'm going to find your NFPA diamond information, as well as your HMIS information. Section 4, I often go to for first aid measures, because you're going to see those signs and symptoms of exposure that is also required in your hazard communication and your laboratory standard. Also, I often go to the section 7, where you've got your handling and storage. So that's going to be anywhere when you're looking at chemical segregation. That's a place that you can go to see if there's anything you need to avoid storing with that chemical. And section 8, you're going to find your control, exposure controls and personal protective equipment. So that's a often used section to look at when you're developing your SOPs. I often go to section 11 as well for your toxicology information to find those exposure limits. So I put in this slide here because I think a lot of people don't realize that they have an additional tool that they can look at to find information on those hazards of the chemicals in those laboratories. So the Laboratory Chemical Safety Summary, the LCSS, it was designed based on the description from prudent practices in the laboratory. I will talk a little bit more about that book later, but in the LCSS, it's going to give you information that is additional but doesn't replace the information you find in the SDSs, as well as those SOPs and lab specific training for each lab. It is, you find these on an open database managed by the NIH, National Institute of Health. This is an open database that's constantly being changed and added. So you're having more information as they find out more about these chemicals and new chemicals that they're adding more sheets to. They're constantly giving us more information and more resources for us as laboratory safety professionals. It's publicly accessible right here. See if I can actually click on this and see if we can look it up.
I put the link in the chat as well for everybody.
So this is what you're going to get if you go to this local website. I like to at least go here because I know we have people here in this group that have only been at their jobs for just a month now. And I know I wasn't using these for quite a while. I didn't know about these for a long time. There is a ton of information for any of these chemicals, a lot more than you're going to find in your SDS. So I'm going to just throw in, let's try, so anything you come up, you're going to have a selection of the different chemicals under that common name. And here is, let's see if I can navigate a little bit through here. So plenty of information for your chemicals here. You got your GHS pictograms that pop up right away, the things that I'm looking for when I go for labeling or SOPs, so to immediately see those hazards. Right here on the side, we have all the different sections of information that are available for this particular chemical. And like I said, they're constantly adding more information. Quick places that you can go to. Oh, is it not going? No. So mostly what I want to make sure to let you guys know, it's a free app that you can go to. The Search PubChem is the name of the app. If you download that app, you're going to get something that looks like this middle picture here. You click on any of these, you can add to these chemicals, anything that you commonly use. You're going to end up with the picture on the right here. That little search button is what you'll click and go to that same website where you can look up any chemical. And like I was saying, unfortunately, I can't get it to pop up for you guys to show you, but it's I use this comment, I keep it in my back pocket, right? So I got this app on my phone. So anytime I have a question about any kind of chemical, I can quickly look up a lot of information very quickly with this app. All right, so we're going to move on really quickly to signage and labeling. Something that obviously I mentioned before, the hazard communication standard was revised in 2012 to include the globally harmonized system of classification and labeling of chemicals. This standardizes the classification of hazards, SDSs, and labeling worldwide. Like I said before, it made all the SDSs under the same format, under the same 16 sections in the same order, so that we can easily go in and navigate through those. The MSDSs were required to be replaced by the SDSs in June of 2015. Now, there are exceptions to that. When I'm going in and I'm looking for their documentation, I still find MSDSs. Usually, those are in chemistry labs where I have chemists that have been there for many years, and they are still holding on to chemicals that are manufactured from companies that no longer exist. So they're not going to be getting replacement SDSs from those companies anytime soon. So there are exceptions to the rule. Of course, you can always ask Mr. Google Pants and find plenty of SDSs for a similar chemical. I also put in on the right here all the different classifications of hazards that have been standardized under the globally harmonized system. So we got those beautiful red diamond pictograms that we're going to be expecting to see on all their labels, as well as on their door signage when we enter those spaces. So here's an example of some labeling that we're going to be looking for. Under the GHS, they should all have these 6 sections that include the chemical name, that identifier. They should have the signal word, danger or warning. Of course, danger is going to be your more severe. You're going to have your hazard statement, which is going to pretty much be a short statement about that product's hazards. You're going to have your precautionary statement to describe any measures that you may be able to take to prevent any exposure. You're going to have your supplier information and those beautiful red pictograms. On the right here, I actually added the secondary labels that we actually hand out here at OSU. These are just samples. There are so many different formats of labels available. This particular one has quite a bit of information that you can add, including those GHS symbols that we like, as well as the NFPA diamond, HMIS that they can fill out, as well as all of their statements. When it comes to secondary labeling, OSHA is only requiring that you make sure that they have the identifier, that chemical name, which needs to be written out. It can't be a drawn structure or an abbreviation. And they also need to have the hazard. So those are the 2 things that we're going to be looking for, the name of the chemical as well as the hazard. Some of the signage, I threw in here just some samples that we actually provide here at OSU. Something we're always going to look for in any lab, even if they do not have chemicals, we're going to look for that emergency information, that emergency contact information. We want to be able to know who to contact if anything happens in those laboratories. On the right is a sample of the signs that we make, because we're going to be looking for all of these things. We're going to want to see the NFPA diamond, which needs to be 4 inches on each side. We're also going to want to see those GHS pictograms of all the hazards that they have in that laboratory. Those are going to need to be at least 2 inches on each side. We're also going to want to see what kind of PPE they require to enter that space. So we actually have a form that people are able to fill out and submit to us, and we can make their signs for them. They're quite a big sign. They can include any other kind of hazard statement that we can add onto the sign. Since here at OSU, EHS is not with the IBC, the Institutional Biosafety Committee. So we don't handle the BSL 1s or 2s, any of the biosafety level signage, but we have plenty of room left on the sign so that they can add it if they want to.
It's also a good spot if there's lasers in the space to have
Sure.
listed.
That's correct. Okay. So after our labeling, we're in signage. That is not all of the signage that we require in those spaces. I would like to mention, we're also going to be looking for things like signage for their emergency safety equipment, their fire extinguishers that also need to be about that have to be 6 inches on each side. Also looking for any kind of chemical storage areas. Those need to be labeled as well. But just wanted to hit the highlights of things that we're going to see right as we enter those spaces. We're going to move on to training. So I know everybody knows this statement. If it's not documented, it didn't happen. But have you also heard, if it's not documented in written procedures, it won't happen? I know Tristan talked about it on Tuesday about the accident at Texas Tech, where they were working with energetic or explosive compounds, and they decided to scale up their experiment to a very large amount compared to what they had started in their small batches, at which point it caused an explosion, and the student in question ended up losing 3 fingers and the sight in 1 eye. And when they asked all of the students and other staff what kind of training or SOPs they had, none of them were able to recall any existing rule that the PIs had mentioned that they had to limit their batches to 100 milligrams. Again, if there is nothing written and nothing trained, then those rules are not going to be followed. Always have any of your SOPs written down and have everyone go over it and document that training. So what are we going to be looking for? We're going to be looking for general training, so that hazard communication training, because everybody needs to know and be able to identify those kinds of signs and symbols and hazards when they enter those spaces. We're also going to be looking for lab specific and personal protective equipment training. So we're going to be looking for them to have training on those chemical hygiene plans that are made for those specific spaces. We're going to look for those SDSs, right, that are going to have the signs and symptoms of exposure and the hazards that are related to those chemicals present. And it's also going to have recommendations for exposure controls and that PPE that is needed to reduce exposure to those hazards. So again, all of this information should be found in the documentation that we mentioned, those chemical hygiene plans that include all of those SOPs, all of those SDSs, and making sure that everyone has gone through that information, has been given a chance to ask questions about that information, and has signed off that they understand. So have your training documented. All right, so now we're going to talk about other sources of information. Some great resources that you guys can look to anytime you're going into these spaces or preparing to go into these spaces. Obviously, I mentioned before that we have the prudent practice in the laboratory handling and management of chemical hazards. This book is actually in the laboratory standard in the 29 CFR 1910-1450 Appendix A. It actually presents recommendations from this very book. I know all of our checklists also have recommendations when we're doing our inspections that are straight from this book as well. So not only does it have information about the laboratory standard, but additional recommendations for prudent practices, safe practices in your laboratories. I also put in here the American National Standards Institute, the ANSI. because OSHA actually references ANSI for guidelines and standards on emergency equipment. Here at OSU, we do all the testing. Our EHS department does all the testing for the emergency equipment, our showers, our drench hoses, our eye washes, chemical fume hoods. ANSI refers to, OSHA refers to ANSI when it comes to those guidelines and standards. There is a membership that you have to get to receive all of the publications from ANSI, but there are plenty of resources. Just make sure you are looking for a reputable resource to get those guidelines and numbers. I also put in here the National Institute of Occupational Safety and Health, the NIOSH, this mobile pocket guide. If you go to this website that I've put below there, it is actually a website dedicated to this app, the mobile pocket guide. It has not only the links to download this app, which is a free app, it also has videos on how to use it and all the features that are available with this app. I have it as well. I use it quite often for building chemical lists of common chemicals that I see across campus, for a quick reference for hazards or any kind of chemical information or segregation questions that I may have. I also put in here the American Conference of Governmental Industrial Hygienists, the ACGIH, mostly because almost all of our institutions, EHS, probably have a copy of the TLVs and BIEs booklet. If you're looking for any of those threshold limit values for any of the chemicals, that is the publication that we're going to be looking for. I also put in the Lab Safety Institute, LSI. Tristan had mentioned on Tuesday about the memorial wall that LSI has, which is a great source when you're looking at lessons learned. It is a very somber page when you're talking about the memorial wall. As it is, he's right, every year we are making additions, unfortunately, to this memorial wall of people who have died in the laboratory setting. But LSI is also a great source for lab safety courses and webinars. This particular LSI was founded by Dr. Jim Kaufman. He is usually the one that is leading these courses and exams, and he is a great source as well. If you get to know him, he is absolutely willing and grateful to have any interaction and talks about lab safety. I can't go and talk about sources of information without mentioning CSHEMA itself. So obviously you guys have found some sort of avenue towards this particular resource, but not only do they have these classes that you're taking right now, but it's also a fantastic resource for a community of fellow laboratory safety professionals. Anytime that I've had a question that I can't ask or can't find an answer on Mr. Google Pants, this is where I'm going to go to find some similar people in similar settings that may have already seen these situations that I may have a question about, or have a really good suggestion or person that I can go to find those answers. Also, I have put in here a link for the American Chemical Society. Again, much like LSI, they got lots of available courses that you can get with the ACS, as well as publications. And another great community, they also have some short videos available. For instance, they have one about what it's like whether or not you should be working in a lab alone. They have a fantastic little video on that. They also do a lot of investigations, just like the CSB, which I'll mention later. So they have lots of information on lessons learned. They also have great information on doing risk assessments and quite a bit of other information. They have a lot of free videos, and some, along with their memberships, they have some additional classes and courses. I also wanted to put in here another app that I use quite often is the Chemicals app. This is another free app that you can use. If I was able to pull this up for you, but it's a pretty simple app. When you open it up, you can do a quick search for any kind of chemical. Again, you're going to have your a quick guide to hazards, signage that you should be seeing, reactivity, so good segregation information. But it also has, if you build your own list of chemicals and chemiochemicals, you can look at it is a great source for your hazardous waste professionals to be able to look at what kind of reactivity when they're bulking, what is going to happen if they mix certain chemicals together. I also put in a mention here on lessons learned. Again, Tristan had touched on this on Tuesday, but there are plenty of universities' websites that have a lessons learned. I put in particular, I just mentioned two, but there are plenty of others. UCLA has a great website for lessons learned, where you can go in, look at incidents that have happened, their investigation reports. They're going to talk to you about what has actually, what was the root cause of incidents, what they were going to do to later prevent those incidents from reoccurring. Also on the UCLA site, they actually have a selection on their website that is, you can easily get to many other university lessons learned websites that is included in their menu. I also put in here the Not Voodoo, which is from the University of Rochester. This is a great little website that is another lessons learned that is not something that was investigations necessarily, but it was originally created for a chemistry department. So on this website, they have plenty of information, not just for accidents that have occurred, but they have plenty of organic chemistry SOPs, troubleshooting, and plenty of other resources for researchers as well as students with organic chemistry. But in particular, they have a section on rookie mistakes that will just give a few lines describing things that have happened in laboratories to these students and investigators. None of these are accidents that have resulted in death, but they're just things that have commonly happened, things like mislabeling and forgetting what something is a week later, which is very common. All of us walk into labs that have a collection of tubes or containers with no labeling, and they have no idea what it is, but want us to get rid of it. Of course, we can't do that unless we know what it is. But this particular website is a nice list to be able to go to realize that everyone makes these kinds of mistakes. I regularly tell young students that I have come and done inspections with that they can go to this website, they can look at these things and see, yes, one, that other people make these mistakes as well, but you can read these mistakes that they've made so that you can learn not to make them yourself. Below that, I have the, like I mentioned before, the LSI memorial wall. Again, this is a much more somber website where it's all accidents that have resulted in someone's death in a laboratory. On there, I will mention later a few of those incidents, but Tristan had already mentioned, for instance, the incident with Sherry Sanji at UCLA with the pyrophoric chemical, as well as the Dr. Vetterhahn, who was experimenting with some mercury. And both of those will be found in this video that I've listed below in the U.S. Chemical Safety and Heart Investigation Board, the CSB video for experimenting with danger. Everybody that comes into our department is required to watch this video. It puts in perspective that where we are working, these accidents can happen and have happened. And it is our job as lab safety professionals to go into these spaces and try to prevent these from ever happening. We always want everybody to go home at the end of the day. So we always make sure that everybody knows that there are consequences that can happen when people are ignoring or don't recognize the hazards around them. So then that's what we're going to start talking about next. We're going to move on from these resources. Hopefully these resources can help you guys when before you're walking into these spaces, as well as while you're going through these spaces, and find questions or want to learn more about the things that you're seeing in these laboratories. So let's transition into the types of hazards we're actually going to see. Because like I said, the root cause of these incidences are going to be failure to recognize these hazards that are present. So what are we going to cover? In this section, we're going to cover toxicity hazards, flammability hazards, reactivity hazards, explosive hazards, physical hazards, biohazards, reactivity hazards, and a little bit about nanomaterials. To start with toxicity, I always like to say, like I mentioned before, everything's toxic at a high enough dose, right? So the dose makes the poison. Of course, when we're talking about toxicity, we're looking at the degree at which that chemical substance can harm an organism. And it's related to both the extent of the exposure, as well as that inherent toxicity of that particular substance. So we're going to be looking at the duration of the exposure. Like I mentioned in those SDSs, that section 11 is going to show you whether or not it's acutely toxic or chronically toxic. Something else that we can look at for toxicity is going to be the lethal dose of that. I should have spelled that out. The lethal dose at where 50% of a species is going to be killed. So we're going to, if the LD50 is very small, then you're going to have a much more toxic substance. Other things we want to look at is the route of exposure. So how is this going to be toxic? Is it toxic by ingestion? Is it toxic by inhalation? Or is this one even going to be toxic by absorption through the skin? So if we know whether or not it's acutely toxic or if it's a particularly hazardous substance, PHS, we know that we're going to have to be taking some additional measures to reduce those exposures. Things that we can also look at are those TLVs, the threshold limit values. We can look at the time-weighted averages, the TWAs. We can also look at the permissible exposure limits, those PELs. All of those can be found with those previous resources that I've mentioned before. So all of them can be looked to find out what kind of toxic hazard we're looking at. So what specific toxins are we going to be focusing on here? We're going to talk about irritants and allergens. We're going to talk about some corrosives, some asphyxiants. We're going to talk about some reproductive toxins. We're also going to talk about neurotoxins and carcinogens. So irritants and allergens, those are non-corrosive with reversible inflammatory effects. So when you are removing that hazard, you should have a reversible effect. Primary irritants have no systemic toxicity. So if it's only an irritant and there are no other hazards related to that chemical, then it's not going to be systemically toxic. Some irritants are sensitizers that have delayed symptoms and can cause allergic reactions with repeated low dose exposure. I put in an example of formaldehyde, but there are plenty of others that, for instance, we regularly see allergies to latex, since those latex gloves. I always recommend that people switch to nitrile to reduce that exposure to latex. Something we always see as well is we have on a research campus, you're going to have animal research. So you have a lot of husbandry staff that are going to be exposed to those allergens related to those different species. So there's going to be additional exposure controls that you're going to want to look at to reduce those exposures to those people working in those areas. So here we're moving on to corrosives. Corrosives are going to cause damage to living tissue at the site of contact. These are going to be very common in the laboratory setting, and they're going to include things like strong acids, strong bases, strong dehydrating agents, and strong oxidizing agents. There's going to be plenty of PPE and other engineering controls that you can use to reduce exposure to these particular corrosive chemicals. You also, when you know that you have a corrosive, you're also going to be looking at segregating those different corrosives. I'm going to be looking for a corrosive cabinet when I go into a lab that has these, but I don't want to see all of those corrosives in the same corrosive cabinet. So I don't want to see my acids and bases together. I want to see them separated. I don't want to see my organic acids and my inorganics together. I want to see them separated as well. Asphyxiants. Asphyxiants are substances that deprive the body of oxygen. They're going to displace oxygen in the air being breathed. Depriving the brain of oxygen can lead to loss of consciousness and death. I don't know about you guys, but I know on our campus, we're dealing with a lot of shortages of helium, and a lot of campuses, along with ours, are trying to design helium recovery systems to be installed in some of our science buildings. So what are the hazards that we're adding to those spaces? Obviously, helium is going to be an asphyxiant, even though usually helium is quite inert. It can displace that oxygen in a space. So what kind of controls can we put in to reduce that exposure? A lot of times we're going to be looking at sensors to put in place, but always keep in mind that if you're going to put in sensors like some sort of oxygen sensor into the room, who is going to be monitoring and maintaining those sensors? So if you have something like a sensor with some sort of lit sign, is it going to be on the outside of the door so that people will be able to identify it before they enter the space? Is there going to be an office that's notified? And who's going to be making sure that that sensor is always working? Moving on to reproductive toxins, we got mutagens and teratogens. So the OSHA lab standard defines them as substances that cause chromosomal damage and substances with lethal or teratogenic effects on fetuses. Anyone who is pregnant or soon to be pregnant should seek advice on precautions to reduce possible exposures, since that placenta is a very poor barrier to chemicals. Obviously, everything you're eating, your baby's eating, everything you're drinking, your baby's drinking, everything you're exposed to, your babies might be exposed to as well. So you're going to want to talk to a medical provider to tell them what kind of exposures you may have in your workplace and whether or not you need to take additional precautions to avoid them. Some organic solvent exposures have been related to increased fetal malformation. Other chemical exposures, such as halogenated hydrocarbons, have been shown to affect male reproductive systems. So it's not just women that we're looking at, but males as well. Moving on, let's talk a little bit about neurotoxins and carcinogens. Obviously, neurotoxins are going to have adverse effects on the nervous system. I dropped in a quick example of mercury. And this one is a chronic toxin. So you're not going to get those immediate effects. This is over a long-term exposure. Carcinogens can cause cancer, or also known as an uncontrolled growth of cells. A select carcinogen should always be treated as a particularly hazardous substance, the PHS, and it will be considered a select carcinogen if it meets just one of the following criteria. If it's regulated by OSHA as a carcinogen, if it's listed as known as a carcinogen in the annual report for carcinogens issued by the NTP, the National Toxicology Program. If it's listed under Group 1, carcinogenic to humans by the IARC, the International Agency for Research on Cancer, or if it's listed under the IARC as a Group 2A, probably carcinogenic to humans, or 2B, possibly carcinogenic to humans, or under the category reasonably anticipated to be carcinogenic by the NTP. So obviously, if it's any way possibly might be carcinogenic, you're going to be listing that as a select carcinogen. So we've talked a lot about toxins, so let's move on to flammable hazards. Obviously, flammables are going to be readily catch fire and burn in the air, and they are very, very common in laboratories. Unfortunately, with all this COVID that has happened in the last couple of years, it's not just in laboratories, it is everywhere. People seem to be stocking up on isopropyl alcohol, even in the offices. So we're having to deal with flammables and flammable storage absolutely everywhere on campus. I put in here a little picture of the NFPA diamond here. This is going to be the top red diamonds is going to be your flammables. I also added in here in this middle picture because I learned something every day. I had the fire triangle, which is obviously those top three, the oxygen, heat, and fuel. If you remove any of those, you are going to starve that fire and put it out. I was corrected. It is no longer the fire triangle. Now it is the fire tetrahedron. So not only do you have oxygen, heat, and fuel that keep that fire going, but all of those are related to the chain reaction of that fire. Still, you have those three main oxygen, heat, and fuel that keep that fire going. So if you're able to eliminate one of those, you still put out the fire. So let's talk about flammability characteristics. So the degree of the fire hazard can be based on these. First that we're going to talk about is the flash point. That is the lowest temperature a liquid has enough vapor pressure to ignite with air at the surface. Many common organics have a flash point that's below room temperature, such as acetone, methanol. I have a lot of diethyl ether in our organic labs. So those are going to be extremely flammable substances. Also, we have ignition temperature, or your auto ignition. This is going to be the minimum temperature needed to cause self-sustained combustion independent of a heat source. So the lower this ignition temperature is, the greater potential for a fire. Also, let's talk about the limits of flammability. You've got the lower explosive limit and the upper explosive limit. So your lower explosive limit is going to be your lowest concentration of fuel in the air, which will burn with an ignition source. So it has to reach a certain concentration in the air for there to be enough fuel as well as oxygen for that ignition source to light that fire. Then you also have the upper explosive limit, which is going to be your maximum concentration it will burn, above which it's not going to burn. So that flammable range is going to have to be between that lower explosive limit and that upper explosive limit, right? So if you have a small room, you're filling it with a flammable gas, it has to reach a certain concentration before a lit flame is going to burn or explode. But if you're filling a room with quite a bit of a flammable gas, and you will actually get to a point where you cause that flammable gas to be an asphyxiant. You're pushing out all that oxygen. So you're starving it of one of those three things you need for a fire to burn, right? You don't have enough oxygen, it's not going to light. So it has to be above the lowest concentration and not above the maximum concentration. It's going to be in that middle range. So since we're talking about flammables, let's talk about the causes of ignition that you're going to see in laboratories. I also put in here just this first one, spontaneous combustion. So those substances that can reach an ignition temperature without a heat source, that auto ignition that we talked about. I put in a little note here, pay close attention to oily rags, mostly because we're on a laboratory and we're on a campus, right? So it's not just laboratories. And we have plenty of shops, right, across campus that are in just those engineering areas, as well as all of our facilities management, right, which is pretty much all shops. So when you're going in these spaces, you want to make sure those people have proper disposal units to deal with those oily rags. Also, so what we're going to see, since we're here to talk about laboratory safety, what kind of ignition sources we're going to see commonly in those spaces. So there's going to be like things like your Bunsen burners, your hot plates, and something that a lot of people don't think about is those exposed wiring. I know a lot of the labs that I go into have some really old equipment. Some of those pieces of equipment have been passed down from one PI to another, and I have found plenty of them with lots of exposed wiring, either on the front or the back, or just a completely open system with half of the machine that's been opened up for repairs. And when you've got lots of flammables in those areas, you are not going to want to see all of those ignition points nearby. Also, something that we commonly see in laboratories are flammables being stored in the refrigerator. Now, it's not that they can't store flammables in a refrigerator, but you want to make sure if they're doing it that they have a refrigerator that is equipped and can handle flammables being stored in them. A laboratory grade refrigerator or an explosive proof refrigerator should be necessary because a regular commercial refrigerator can have, I believe maybe from 11 to 14 different ignition points inside of that refrigerator. So if they are storing a lot of alcohols or some ethers in those refrigerators, then those vapors are eventually going to be put off of that flammable liquid and can build up in that sealed space. And think about all the times that the compressor comes on, or a light or an indicator light, or that the thermometer that, your thermostat that is clicking on that compressor, any of those things can light up those vapors and cause an explosion. We've actually had these happen on campus. We've been lucky enough that they've been near misses where a student was standing just about 1 to 2 feet away when a refrigerator under the bench top exploded and just barely missed them when the door came flying off and hit the wall behind them. So this does happen. And so I wanted to make sure to put that in there, that we are aware that people are not storing, those investigators are not storing flammables in just a commercial refrigerator. So after flammables, we're going to talk now go into reactive hazards. So the first ones that we're going to talk about here are those water reactives, those that are going to be obviously violently reacting with water, with liberation of heat that can ignite a flammable or release a flammable, toxic, or strong oxidizing gas. These water reactives can cause issues with responding firefighting personnel So that's why I put this symbol in there. This is the bottom diamond of that NFPA diamond. So you can put this symbol, this water reactive symbol, an indicator for any of those first responders that are coming into that space. Down here, I put some examples of some water reactives. I think the ones that I commonly see are going to be those aluminum, sodium, we see a lot of that, some magnesium as well as these others here. And mostly we're going to see these that are contained in some sort of mineral oil to keep them completely submerged and not able to be exposed to water that might be in the air. I also put in here in the reactives the pyrophorics. These are going to ignite from exposure to oxygen or water in the air. On Tuesday, Tristan had mentioned, I put this picture down here at the bottom left of Ms. Sherry Sanji, who had been working with the tert-butyl lithium when she had it in a syringe, pulled the plunger, and the plunger came out, which sprayed the tert-butyl lithium on herself, caught her on fire. There were also some other flammables that were being stored in that hood as well that just caused quite a big fire that unfortunately led to her death a few weeks later. Something I also, I put in here, a picture on the right is something that I experienced myself here on campus at OSU. I had a chemistry lab that were quite proud of themselves that wanted to show me these pictures of some phenol lithium that showed up on campus, made it all the way to their laboratory, but they were quite proud to tell me that I shouldn't need to worry, because when they opened it, they were using all the proper PPE and had a fire extinguisher right near them.
They had somebody there with it ready to use.
Yes, they did. Once I picked my jaw up off the floor, I asked them, why in the world did you actually open it? If you obviously saw that this container was damaged, not only was this damaged and they opened it, but they accepted the package, right? If something comes to you, that box below there, you can't see it, had stickers all over it, talking about how flammable this particular chemical was. This went through our mail services on campus, it went through a chemical store, and then it came up to the PI, and all of these people accepted this package. And all because they just weren't aware of the hazard that this really could have exposed them to. If maybe they had known the story of Sherry Sanji, maybe they would not have been so keen on opening this package. So I like to have these stories in my back pocket for when I go to these places and I see these chemicals, to say, hey, do you know the story, this story? And do you know how hazardous this really is? There really are consequences when you expose yourself to these hazards. Also under reactives, we have incompatibles. Many chemicals can produce violent results when mixed with other chemicals. We always put in, I dropped a picture of a guide that we put into our template for the chemical hygiene plan on campus here. Proper chemical storage systems should be in place to separate chemicals by hazard classes. But of course, this one I put in here is just a guide. Every laboratory is going to be different. They have different chemicals in those laboratories that'll need to be segregated in a different fashion. Of course, some of them might have some particularly hazardous substance that shouldn't be with any of them. It should be completely separate. Every lab is going to be different. There are plenty of other different guides, but always refer to all those resources that I mentioned before, as well as others that you can look to help you decide what kind of system would be best for you and what to avoid storing some chemicals with others. On the right here, I inserted a picture from another picture from the Chemical Safety Board. This one in particular is from the AB Specialty Silicones explosion that happened in 2019. This is an industry, and it's not a laboratory, but every story has aspects that can be translated to a laboratory as well. This particular production facility was making a silicone sealant that used silicon hydride. And when they were making multiple batches, they changed shifts in the middle. And after making one batch that had needed to be pH balanced with some potassium hydroxide, they had left all of those chemicals out and together. There was no segregation. There was no color coding of anything on any of these chemicals. So when the second shift came in to make another batch, they mixed all of these drums together. If you can see in the right corner of these blue drums, they're just all stacked together over here. There's no kind of segregation there. So they mixed these chemicals together, which released some hydrogen gas into the building. Once they noticed this buildup of gas, they called in more people who decided that they were going to try and turn on the exhaust fans. Unfortunately, they were too late. They had finally reached that lower explosive limit where there was enough of the fuel in the air in the building mixed with enough oxygen that it exploded, killing all 4 of those men that were on the floor, as well as injuring some others. There are plenty of other stories when it comes to this kind of chemical reaction, explosions and fires. Even in Buffalo Wild Wings, right? In 2019 in Massachusetts, there was an employee who was just trying to clean the floors. He put down an acidic detergent on the floor to strip the floors. And unfortunately, he didn't realize when he pulled out another bottle of bleach and poured it on it, that he was going to be releasing chlorine gas into the kitchen. He started feeling nauseous. He comes out, he tells the manager does the right thing and starts getting everybody out of the building. Unfortunately, he made a mistake by going back into the building to try and clean up the spill. He tried to squeegee all of the chemicals down the drains where he was just mixing them even more. And by the time emergency crews got there, it had caused enough damage to the young man's lungs that he did not survive. And we had a 32-year-old man who thought it was just cleaning supplies that he had to clean and push away, and that didn't end up going home to his new wife and new baby. So it is always something I see on a regular basis, people not segregating their chemicals, and it's something that is definitely a hazard in those spaces. So next we're going to talk about explosive hazards. So when subjected to initiation, these particular chemicals undergo rapid chemical change, releasing large volumes of gases that exert pressure on the surrounding air and material. Hazardous polymerization can produce dangerous amounts of heat. Some examples are azos and peroxides. Those are commonly used as free radical sources and oxidants. I'd like to mention that peroxides are more shock sensitive than TNT. I know everybody, I'm way too old. I immediately go to an episode of Little House on the Prairie where they're transporting dynamite in the TNT. Yep. But in the peroxides can be even worse. We're going to make sure that refrigerators, I see a lot of these peroxides that are being kept cold in refrigerators. Again, make sure they're appropriate refrigerators. Also make sure that you have backup power. A lot of these, I have found refrigerators and storage sheds here where we keep chemicals that have no temperature control whatsoever. They're keeping these refrigerators and freezers and no backup power as well. So in the heat of the summer, what's going to happen if the power goes out when you're storing those chemicals? Also, I mentioned in here are powders and dust. Oxidizable powders in the air constitute a powerful explosive mixture. So you want to isolate them from ignition sources and use adequate ventilation, because those dusts have a very large surface area compared to their mass. So of course, when mixed with that oxygen, you're going to increase your flammability. Also, when we're talking about explosives, I wanted to talk about peroxide formers. These are chemicals that react with air, moisture, or impurities to form peroxides, which is greatly increased by evaporation or distillation. Many of these peroxide forming chemicals are commonly used in organic solvents. I see quite a few peroxide formers on campus. We track these. We want to make sure not only that they're tracked for disposal by those PIs. So when they purchase them, when they arrive, they need to put a date on them. They need to put some sort of label that says that this is a peroxide former, and they need to make sure to dispose of them within a certain time period, depending on what class of peroxide former it is. We track these as well in our department. We come and do peroxide former testing. And I don't know about you guys on your campuses, but something I put down our list that we include in our chemical hygiene plan. This is not all inclusive. There are plenty of other peroxide formers, and the peroxide formers that we see the most aren't even listed here, which is secondary alcohols. I don't know about you guys on your campuses, but we see a ton of old secondary alcohols because people just don't think about it. It's just an alcohol, so why get rid of it? So when we come in and we find these legend alcohols that have been passed from one PI to another PI to another PI, we come in, we test it, and sure enough, these are the ones that fail our peroxide former testing the most. So these are something that we regularly see and regularly track. And honestly, I don't really know how dangerous they are. I haven't found any publications that talk about explosions when it comes to secondary alcohols, unless they've been heated. But I am more than, I welcome any additional information that you guys have, or whether you guys have this problem as well. All right, so now we're going to transition into physical hazards. First one that I listed here is going to be compressed gases. Obviously, a compressed gas can be both a mechanical as well as a chemical hazard. So we've already talked about a lot of those chemical hazards, right? We're obviously going to have flammables, oxidizers. We're going to have poisons as well. Those compressed gas cylinders can obviously be a big physical or mechanical hazard, as that broken valve can propel that cylinder through a brick wall. We actually have had cylinders that have fallen over and the valve break, and they have pushed the wall inside, I believe, like a 4th floor of a building. It pushed the wall several inches over, and you were unable to close any of the doors or anything in that particular room. So we do have this hazard everywhere on campus, and it is a real hazard. So it really can cause a physical damage to anybody that is nearby. A cylinder of compressed breathing air used by a scuba diver has the explosive force of 1.5 pounds of TNT, just air in this compressed gas. So make sure your cylinders are properly secured, use proper regulators. So there are specific regulators for different kinds of chemical. So you're going to have one that's going to fit on an oxidizer, and you're going to have a completely different one that's going to fit on a flammable. And you want to make sure those PIs and those students aren't jimmy rigging those regulators to work on different ones, which I have had people just taping and wrapping regulators to try and make it work because they didn't understand why this coupling wasn't fitting right. It's like it's made not to fit right. There's reasons why we segregate different regulators. Also, we want to have caps on those cylinders when they are not in use. And we want to segregate them properly, just like we want to segregate our chemicals. We want to segregate our gas cylinders. We want to keep those oxidizers, that oxygen, 20 feet away from our flammables in a completely different rack. So what other kind of physical hazards do we have? We've got cryogens and autoclaves. This is going to be a burn hazard. So even a brief contact with cryogenic liquid can cause tissue damage similar to thermal burns. So make note of also any heated or cooled equipment that's nearby that must be handled and require the proper PPE. I put up here 2 examples. So those orange and those blue gloves. Obviously, you're not going to be wanting to use those orange gloves when you're dealing with a cryogenic liquid. You're going to want to deal with something that's more liquid proof here. So you're going to want to specifically look for something for cryogens and something for a burn hazard. Also in here, I put high pressure reactions and vacuum work under our physical hazards. Luckily, I do not have a story like Tristan did of a particular high pressure reaction that caused a significant damage to anybody. And unfortunately, he had a death that he had to deal with. We're going to want to make sure the equipment can always withstand or exceed the temperatures or pressures involved in an experiment. When we're also going to want to look for barriers that can be placed in the front of this equipment, as well as proper PPE. So you're going to be looking at face shields and other eye protection. Anytime we see something, I put in here a picture of a rotovap. Usually those are dipped in some sort of plastic, so they have some sort of protection against part of the glass breaking. The rounded flask usually does not have any kind of protection. So there's going to be your failure point where you're going to want to still make sure that the personnel have the proper PPE to be around that equipment. Also, our physical hazards, we have electrical hazards. So there is a risk of electrocution, but it's going to be low in these laboratory settings, but it is still a serious injury that could occur from malfunctions, ill-formed modifications. I know in our engineering department, we have plenty of people that decide that they can either open things up and fix them themselves or build something completely new. And there's always a risk of electrocution there. We also want to look at damaged wiring. That can often happen when you have all of these UV lights in your biosafety cabinets. They forget that all those plastics can become very brittle. And once you move around those cords, they can break and expose those wires as well. And we also want to look to make sure that we're trying to avoid any kind of flammable vapors that are stored around any kind of electrical equipment that could cause sparks. I put in here quite several pictures that we commonly see on our campus here. We often see things like daisy chaining that we want to avoid. Also, GFCI installations, we want to see those near those sinks or any kind of water source. Obviously, we have buildings that are quite old on these campuses, right? So a lot of these buildings were put up before the building code required these GFCIs to be within 6 feet of any water source. But that doesn't mean that it gets grandfathered in and they're totally okay. They still have to protect their employees. So those GFCIs are recommended in any of those spaces. We also want to make sure that they're routing their cords safely, obviously not through water, not over sinks or inside of them. Always, quite a few times we'll see those sinks that run down the center of the bench tops, and they will decide that that's a really good place to store extra cords. But what if someone accidentally turns on that sink? It's very easy to knock one of those on, or just not notice a cord that's wound up on the bottom of it. Also, you want to make sure that those breaker boxes are not blocked. That picture on the far right is actually in an electronics lab for students that are building their own circuits at those tables on the right. So if anything actually happened, how would they be able to get to the breaker boxes to shut them off? So we always want to make sure that those are not blocked. Also, something physical hazard we might see in the laboratory are ergonomic hazards. The laboratory personnel, they work at computer stations just like any other office personnel. Of course, they also do repetitive work, such as using pipetters. They also work at bench tops that they're having to bend over or stand in front of for long periods of time. They're using microscopes that require repetitive movements and can cause injury. There are cameras that are available to hook up to microscopes, or specific eyepieces to avoid ergonomic strain, and other special equipment such as pipetter, ergonomic designed by pipetters to reduce this strain from these repetitive tasks. So just like in any other space, we're also going to deal with slip, trips, and falls in the laboratory, maybe even more so, because not only do you have your regular slip, trips, and falls, but then you're going to deal with things like spills from chemicals, right? So we also want to make sure, just like in any space, that we have good housekeeping, and this can greatly reduce this hazard. We also want to use carts and rubber buckets to reduce spilling chemicals during transport. We also want to clean any spill as soon as possible. We don't want anybody else walking through that area and causing an additional injury. Also, we want to try and store difficult to handle equipment and contain large containers of chemicals at comfortable heights so that we're not straining and we're not likely to drop or spill anything. I actually put in a picture here on the right that's actually from one of our labs in the geology department, who decided it was totally okay to put all of, when we asked him to clean up his lab the first time, that it was okay to shove it all into one small room, which if you can see behind there is also where he has all of his emergency equipment. So obviously you're not going to be wanting to block any sort of egress when you're cleaning up. You want to clean up everything and put it away out of all of your walkways, and especially around your emergency shower and eye washes. So we're going to touch a little bit on biological hazards. So where are we going to be seeing these on our campuses? We're going to be seeing these in labs that have research pertaining to microorganisms. We're going to have an institutional biosafety committee, the IBC committee, that will come in and guide these labs with assessment and regulatory security requirements pertaining to their biohazardous protocols. But we always want to see the signage that lets people know and are aware of that hazard when they enter that space, and any kind of additional information and PPE that they may need when entering. We are also going to see biohazards with any labs that are doing work with human blood or other potentially infectious materials. Those are going to be under that OSHA bloodborne pathogen standard. So those labs are going to have a lot of additional paperwork and documents required, and training, annual training in bloodborne pathogens. Also, we're going to also see biological hazard in quality control labs. We have labs that do quite a bit of work with our water supply as well as sewage treatment. So that is also going to be under a biohazard. Just a little bit of information here on radioactivity. Obviously, you're going to have your radiation safety office. So you're going to have a radiation safety officer designated at your institution that's going to be heading that regulatory information for those particular labs. Obviously, when I talked about the OSHA standards, though OSHA is not the only regulatory agency that is going to have standards for these laboratories. Right here we have the 10 CFR Part 20 that's going to regulate those particular labs that use radioactive materials. This is regulated by the U.S. Nuclear Regulatory Commission, US NRC. The different types of radioactive that we're going to see, it's going to be alpha, beta, proton, neutron, and gamma. Any of those acceptable limits are going to be set by the US NRC. Mostly what we're going to want to make sure is that they're using ALARA, right? That as low as reasonably achievable. So we want their exposure to be as little as possible. So how are they going to do that? We're going to make sure that they have plenty of shielding and distance when it comes to using these radioactive isotopes or X-ray machines or anything that's going to have any kind of radioactive hazard. So I also want to touch a little bit on nanomaterials. This is when they are scaling any object to a nanoscale, which can change its chemical and physical properties. It can also change the hazardous properties. It can make things more flammable, like we talked about before, those dusts. If you're making something, you're increasing that surface area, you have more surface area to burn, you have more surface area that's mixing with more oxygen, you can increase that flammability and explosivity. There is limited guidance right now when it comes to nanomaterials. So there's obviously going to be issues when it comes to determination of the hazards by EHS. Something that we do know a little bit about is that inhalation, there is an inhalation and ingestion hazard that can be reduced by suspending any of those nanomaterials in a solution or a slurry. Also, using proper ventilation is going to help. Like I said before, there's those reactive and explosive hazards have been shown to be greatly increased when you bring chemicals to a nanoscale. And there may be some specialized equipment that may be needed to evaluate those exposures and releases. I mentioned in here that low flow hoods may be appropriate, but at this time, there is nothing that says that we should be using low flow hoods. We still have our regular chemical fume hood standard of us wanting to have a safe operating operation at 80 to 120 feet per minute face velocity. So it's something that we may look into. It's something that might be helpful in some of these situations, but at this time, there's not a lot of guidance when it comes to determining whether or not we need to switch over to a low flow hood in these situations. So we still have about a half hour left here. So there's a big switch here and a transition into risk assessment. So we've talked all about the information and resources that you can use when you're coming and doing these inspections and assessments across campus in these laboratories. So risk assessment includes identifying these potential hazards as well as analyzing what could happen if that hazard occurs. I also, when we talk about risk assessment, we want to talk about the difference there is between a hazard and a risk. So we obviously, we see and identify hazards, and this is something that has a potential to harm you. So what's a risk? A risk is when it is the actual likelihood, the probability that that hazard is actually going to cause you harm. So I like to put this one in here. Obviously, a shark in the ocean is a hazard. Swimming in the ocean with a shark, that's a risk. So what are some common assessment methods? I listed here just 5 different methods that I have commonly used when I've started at this position. So one of them in particular is going to be a what if analysis. It's pretty much just brainstorming to determine what can go wrong in specific scenarios and identifying the resulting consequences. And we also have a job hazard analysis. We do these, I'm probably doing one of these at least once a week. These are a good tool to identify hazards associated with a particular job or task. And so we're doing a dry run of an experiment is a notable type of a job hazard analysis. And those hazards are identified and recorded, and control measures are developed for each of these hazards. We also have checklists. We use a checklist every day when we are doing this job as lab safety specialist here at OSU EHS. We take this, went ahead and dropped just the first page of our survey checklist that we do for all of our annual laboratory surveys across campus. These particular checklists are a structured process for hazard and risk assessment, probably the most commonly used method when it comes to risk assessment. Fourth one we have is the standard operating procedures. The result of this method is a really comprehensive document. It's going to outline the processes in the lab and identify hazards and controls to eliminate or mitigate those risks. Our last one that I have listed there is control banding. This is probably the least common that I have used. This particular risk assessment and is assessment and rating that prioritizes hazards based on levels of risk and exposure, which can lead to appropriate control measure selections afterwards. When doing any of these assessments, you're going to be asking some pretty common questions. So here's 5 common questions you'll be asking when doing any of these risk assessments. First, what are the hazards? So obviously we've been talking about any of the kind of common hazards that we're going to see in these spaces. Obviously, like I said before, we're on the cusp of new research every day, and there's new hazards every day. So obviously there's a lot more than what I identified. I've only touched the surface. So when we go into these spaces, we're going to be trying to be thorough and look for what are the hazards in that space. We also want to ask, what is the worst thing that could happen? So usually we're coming in or asked to come in to assess a particular procedure. So we want to look through that procedure and see what's the worst thing that's going to happen, and so that we can further move on with our assessment. What can be done to prevent this worst thing from happening, right? We don't want it to happen. We don't want anybody to get hurt. We want everybody to go home at the end of the day. So what can we do to prevent this? Also, what can be done to protect employees from these hazards that we have found? Obviously, we have lots of suggestions that we have from our SDSs and all of the other resources that we mentioned before. So we're going to try and employ those different engineering controls and administrative controls and the like to reduce that hazard or exposure to that hazard. And the last question I put here is, what should be done if something goes wrong? So in any of our SOPs, we always like to put in emergency procedures, emergency contact, as well as spill procedures in case it may be something that's less hazardous and we just have to deal with a spill, which is great. Or we may have something very significant that we're going to have to call in additional help on campus. So as we continue with our application of risk assessment, how do we make it more effective? Well, first of all, you're always going to want to involve the employees. So as safety professionals, we're walking into an unfamiliar space and process where we're going to want to bring in the people that have hands-on experience, that actually use that equipment, that know the chemicals that are going to be used, and will actually be able to identify things that just aren't going to work, right? They're the ones that are going to spot some sort of missing step. They're going to spot a control measure that we might suggest that's just not going to work for their particular situation. So how else are we going to be more effective? We're going to want to review previous accident history, right? Just like that lessons learned. We went to all those websites that are an excellent source of education and knowledge when it comes to knowing something that has previously happened and maybe looking at how they were able to prevent that from happening again. So we want to greatly improve our chances of avoiding making that same mistake or creating that same accident, and looking for a specific way that we can prevent them from reoccurring. So also in here, we're going to want to identify task level hazards. So when we walk in and we identify hazards, there are going to be additional hazards in every step of any sort of procedure or experiment. So how are we going to access all those different steps? I just dropped in here something that we use specifically in our department at OSU, a job hazard analysis. Again, this is one of those methods that I previously mentioned, but this is going to break everything up into a sequence of steps. It's going to look at the particular hazard at each different step because they could be very different. And you're going to want to rate each step with not only how severe that harm may be, but also how likely it's going to happen, right? So you're not just looking at the harm, but you're looking at the risk. And depending on how severe that particular hazard may be, or how risky that particular step or procedure may be, then you can go in and look at what kind of control measures that you can use and put in place to reduce the exposure to that hazard. So these actually are the job hazard analysis and the probability hazard score, as well as the priority ranking matrix, is something that we provide to all of our personnel here on campus. All of our laboratories have a copy of this in their laboratory safety manuals and their chemical hygiene plans, just for them to reference for that. So we're not the only ones that are going to be doing these risk assessments, right? Even those primary investigators are expected to go in, look at those experiments, figure out how hazardous they are for themselves, as well as those employees or students that are coming into those spaces, so that they can protect themselves as well as those students. So now you've actually done some sort of assessment on those hazards. You can use this to implement safety controls to reduce exposure to those hazards. So we're going to implement a safety plan based on the hierarchy of controls. Everybody knows this beautiful inverted pyramid here. Obviously, the first thing we're going to want to do when we're trying to reduce this exposure is start at the top, which is going to be your most effective way of reduction of hazards, which is starting with the elimination when you're able to physically remove that hazard. If you can't eliminate it, then what are you going to do? You're going to try and substitute it with something that's less hazardous, right? Most of the time, that's not possible. Now, obviously, those PIs have already worked out what they need to use. So if we can't replace it with some sort of substitute, then we're going to want to look at engineering controls that isolate the people from that hazard or isolate that hazard itself. If that doesn't completely reduce exposure, then we're also going to want to look at administrative controls. These are pretty much rules that you put in place to change the way people work. A common one that you're always going to see in every laboratory is do not eat or drink in your labs, right? Easy way to expose yourself by ingesting something that's in your workplace. So don't eat or drink in there. Don't change your contacts and touch your eyes when you have just been handling dangerous chemicals, right? Wash your hands after removing your gloves. It's going to help reduce any kind of exposure to yourself even after you've left the workplace, right? And there's lots of other administrative controls that you can put in place when you can't use all the previous steps above to completely eliminate that risk. But if you still have an exposure after all of these controls, you're looking at your last step, the last protection between that hazard and that employee, which is going to be your personal protective equipment. I don't think that most laboratories think about PPE being their last step, but it really is the least effective step in reducing exposure. And it's always the first one that they think about. But if you can take away those hazards before you even think about it, that PPE is not nearly as necessary. So after we have gone through all of our assessments, we're going to want to actually start writing our standard operating procedures. So we've gone through all of our steps. So we obviously already have a nice list of our experimental steps. We're also going to want to write down what were those hazards that we found for each of those steps. We're also going to want to write down our engineering controls and PPE that are recommended for each of these steps. We're going to also want to include storage and safe handling of any of our hazardous chemicals that are included in that experiment. A lot of times we forget about, we've just been handling a lot of hazardous chemicals. What do we do with them with what's left over? So you're going to want to put in there some sort of plan for waste disposal. Of course, you've asked them what's the worst that can happen. Well, you also want to add in a first aid. So you want to have some sort of emergency process included into that standard operating procedure, as well as a spill and cleanup procedure, which should be included in anything with a hazardous liquid chemical. Also, the one thing that I've probably mentioned several times already is that documentation. Make sure that you're including something in there that some sort of documentation that someone has gone through that standard operating procedure, understands all the steps and all of the hazards and PPE that can be used. So how do you put it all into action? So we've already done a risk assessment. We've already written out our standard operating procedures. Now it's time to start actually training your personnel using that SOP. So something that I always recommend, because part of being at EHS, a service that we provide is helping them write these standard operating procedures. But when I am done and I walk away from it, I always recommend that they go in and actually practice it. They go in and do a dry run. Like I said, it's those employees that are going to be the ones that recognize that some of those control measures aren't going to work, right? And you're not going to know that unless you actually go through those procedures, right? And as soon as you actually have these people go through and find out what works, they have it all written out, make sure that you are having all those personnel sign off that they understand it and that they are going to do it, right? And anytime that you find those personnel that aren't doing it properly, then maybe they're forgetting to wear some of the PPE that's recommended, or maybe they're walking away from their experiments when it needs to be monitored throughout. You're going to want to come in and repeat that training. I don't think we stress it enough that training is probably the biggest part. It's the biggest action when it comes to hazards and risk. It's the doing, right, that matters. It's that hands-on. And that's the part that they're going to want to actually remember, right? This is the part that actually comes to mind, is when they actually did it. It's not that time when they actually read through a procedure in the first day that they started working. It's going to be those moments when they were walking through and actually doing the actions alongside someone who is knowledgeable, that they can ask questions with. And that's when they're going to be more comfortable in actually following those examples of being safe in their procedures. So that's pretty much all I have got. I left just a whopping 15 minutes here for any kind of discussion or questions. Unfortunately, I wasn't able to go in and show you some of the websites, but I hope that you guys at least have this resource with you now so that you can go in and learn more about these resources. There are plenty of others. I am only touching the surface. There are so many other apps, so many other websites, so many other publications that are helpful. And obviously, you can reach out to people at CSHEMA, who have been a tremendous resource for our department here at OSU, and we hope to be a resource for more people as well. So I always welcome any kind of feedback, as well as questions, or absolutely any kind of direction that you guys think that we should go in as well. So that is all I've got today, guys. Hopefully you've gotten a little bit more information and become a little bit more comfortable in going in and trying to recognize and assess these laboratories in the future.
So Katie showed me she explained to me how we can go in and look at the websites if you want to share, and we can go look at Voodoo or whichever website.
Let's see.
And I was sorry, I was spamming the chat with all kinds of other links as well. So
no, those are some very good
things
links
in there.
Yeah, there's so much. There's so much. I didn't want to cram just a ton of websites and resources into this. It's just, I realize it's just a one-on-one, right? So for the most part, and I know that we've got a few people that are just starting out in this job position, and I hope that at least it gets them started, right? At least they have somewhere to go to get started.
Katie was also keeping track of all of those links that you sent out, as well as the ones I was sending out, and she'll send another kind of summary email with all of those links that were in the chat. So if you didn't catch them, you'll get them in an email, which is great.
Fantastic.
Tristan, I wanted to circle back to one of the comments you made about the nitrile gloves. So you guys had some allergic reactions to the nitrile?
Yeah. We have had a few, and it's been kind of anecdotal that I've heard of it at other places. But I talked to a PI, he's a doctor even, who said he has had reactions. Now it started in the last 2 years after COVID, because, supply chain issues and getting gloves of, questionable provenance. Right. And it's apparently the activator when they make the gloves. There's leftover activator in cheaper gloves. I wouldn't say that's necessary. If you spend more money, it may or may not be a problem. You can't guarantee that, but better, more reputable companies will have less of those issues. But yeah, definitely. He said, yeah, he gets a skin reaction to it, to those gloves, which
Right.
I hadn't really heard of until sometime this year. So
I think we had one at AR.
Did we have one at AR too?
I don't remember if it was nitrile, but I do remember there was a box of gloves that whenever I was using them, you got sweaty, you just started having breakouts up your arm. Me and 2 other employees.
Yeah. I think we have probably the most irritants and allergen issues with our animal handling and animal
Absolutely.
resources here on campus. Those people are spending their entire day in PPE, and so they are having the biggest or most issues with those sorts of exposures.
I have a question.
Sure.
So I was wondering, hazard and risk assessment, is that a regular service that you'll do for your labs, and how does that work for you? So do you actually assist labs in doing hazard and risk assessment for their specific?
I usually, sorry, no, go ahead.
For their specific laboratory and hazards.
Well, we're always doing annual surveys of the lab. So we're doing an assessment of the entire lab space. I showed just the first page. We have an 11-page checklist that we're going through for our annual inspections. Those are going year round. We're conducting those surveys, but also by request, anytime we have new PIs come into space, or we have some PIs that are just starting with a new experiment that they've never done before, or using a particularly hazardous chemical that they've never used before, and they will call us in. I love it when they do. They will call us in and ask our advice. So we come in, we usually look through all of their equipment, all of their chemicals, and we go step by step through their experiments to help them write up SOPs and include any sort of control measures that they need to add to those SOPs. Again, that's usually by request. And I hand out my card. I've gone through boxes and boxes of my cards here on campus. I want everybody to have a way to contact me if they ever need me or anyone else in our office. We also hand out tons of magnets with our general office numbers on them. And even I'll walk by one of their refrigerators and just toss on a magnet.
It's a race to get rid of them.
And just to make sure that if they ever have any kind of question, that they're not afraid to call me or email me, so that they know that I'm a resource and that I will spend the time to look through all the hazards that may be involved in any experiment that they're doing.
Thank you.
Mm-hmm. I'm sorry, I've been looking to the side through this whole thing. I was telling Jody before we started, I've got a whole new setup here, and I'm pretty much looking at a big screen TV and I have one of those 360 cameras in front of me. So I've been staring off to the side. A whole new setup. I've never done it this way. It's been interesting.
Yeah, I also have another follow-up question.
Sure.
sorry if I'm asking a lot of questions, but
No, absolutely not. Absolutely not.
physical hazards, that's usually the challenge that we run into because it's not one of my expertise. And so how do you deal with something like that when you don't have the expertise that you need within the department?
Well, luckily I have a pretty large department. I have a lot of people I can lean on. So me in particular, I specialize in laboratory safety. Like I said before, I've been in labs, I've worked in labs for a lot of years. So that's my niche, right? So those chemicals and those hazards that are in a laboratory that I've been exposed to, I know I have more knowledge of those sorts of things. When it comes to other physical hazards, I usually lean on sometimes our occupational health, and we have an occupational safety team as well in our environmental health and safety team. We have fire and life group as well in our environmental health and safety. But if it's something I just, none of us have any knowledge of or experience with, I'll be honest, I've come to SHEMA and I post things in there. Or I make someone else post it because hey, Kim, post this question on here because I have no idea what to do. But I definitely try to use as many people around me as a resource. I like to build those relationships. I guess that's my probably the best tool in my tool belt, right? Those soft skills that Jody spoke about, reaching out and being able to pull in other people. We've even pulled in people from facilities management when we've had to deal with air exchange issues in laboratories. So I'm trying to field it with the local group here. And if I can't, I'm pulling in people such as, I'll call up Tristan maybe, see if he's got an answer.
Probably not, but maybe. I was going to say physical hazards are really tough. They're somewhat unique in a lab typically, and they all are really easy to overlook. One we run across rarely but is serious is like machines, like bandsaws, machine tools, those sorts of things. And those have their own whole thing in OSHA as well. So that's a whole bag of worms you really don't want to get into if you can avoid it, but you probably do. We rely a lot on our occupational hygiene people. I'm lucky in that I'm also an industrial hygienist, so I kind of live in both worlds. So that helps a little bit, but yeah, I mean, it's a tough. Physical hazards are really, they're easy to overlook. They're easy for the lab to not recognize as well, and getting them to understand what those hazards are can be difficult too.
Especially when they're building their own equipment. That's like an added challenge. You're not just buying something that's listed from a company, you're actually like building it. So it doesn't have to be built to specific, requirements.
We keep talking about doing a webinar roundtable about that. And I think we need to do it at some point, not before the conference, I'm sure, but maybe sometime this fall.
Yeah.
So
I would love to benefit from a webinar like that.
Yeah. Yeah, we regularly see, there are so many labs on campus that have, like you said, bandsaws, circular saw, sanders, all kinds of stuff that have so many pinch points and other things that a lot of times you just walk right past and not think anything about. And we include it in our checklist as well, machine guarding. And we try to cross-train our laboratory personnel on machine guarding as well. Luckily, OSU has a engineering teaching group that regularly does OSHA training on those subjects. If you can find some OSHA training for something like a subject on machine guarding, or, you know, they're just, like I said, there's tons of resources. Industrial hygiene and fire and life safety are degrees that are given on our campus. So they have a lot of classes available that you can join in. And professional development is very encouraged here in our EHS, hopefully with yours as well. So you can try and jump in and learn more and cross-train everybody in your group.
Well, thank you, Val, so much for doing this presentation. It was amazing. Loved every minute of it. And again, sorry for spamming all those things in the chat, but I thought they were helpful and relevant. Some of them have come up in the last week for me. So I was like, oh, I'm going to send this too.
Yeah.
But thank you so much for presenting as well. To everybody who was a participant, you know, you have our information. You should have our information, and you'll get it in the slides. Please feel free to reach out to us. We're here to help. I love talking to people and helping them with problems. If you're a member of SHEMA, post stuff on the SHEMA lab safety practices discussion board. I'm one of the co-chairs, and so is Bogna. She's my co-chair. And we meet every the first Thursday of every month at 3 p.m. Eastern. It's a great time to kind of get together and just talk, go through things that are on the discussion board most of the time that haven't been discussed in depth or that are relevant, and gives people a chance to come and ask those questions about, like, hey, I have this physical hazard that I ran across. What would you do? Or what helpful things would you have? So if you need to run, I understand. Go ahead. If other people have questions, we can hang on for a minute or two more, I think.
Yeah, no problem.
Thank you, Tristan and Jolly. So I
Thank you,
was so late. Sorry, guys.
It's fine. I was late too. I really misjudged running an errand and trying to get home.
Yes, same here. I misjudged like 1 hour and a half, so like my fault. Yes,
Yeah, I
but
got the
the
car.
presentation was awesome, like truly awesome. And all those links, they have a lot of homework to do.
I know. I cut it down. I had even more. I was like, I need to not put so much in here.
No, but it's really great. Like from the chemical hazards, like I'm doing so many refreshers, like with different companies. When we have like here our team, and it was such a good new way to put all those hazards in, like fully understandable for everyone who was attending. Like it's so cool. Like really great job on presentation.
Thank you. I just hope I was able to at least touch the surface for some folks. So
I mean, 2 hours is like the absolute bare minimum time needed. And that you did a really great job of balancing that. It's like an impossible task.
I know I cut out
like,
so much.
half an hour on safety culture, no problem. I can do that. That's easy. 2 hours to go through hazard identification and risk assessment. I don't know.
I was trying to talk fast.
That's the way that goes.
All right.
Okay, awesome, guys. Have a nice afternoon.
You
And
too.
have a
Magna.
nice long weekend and no rain.
Yes.
Only for the
Oh,
plants.
no
Only
rain.
for the plants a little bit, but no rain.
I'm driving up to the mountains and it's going to pour rain all day tomorrow. So
Oh,
We've
have to
had
drive
3
through it.
solid days.
Yeah.
3 solid days of rain.
It's coming my
yeah,
way.
yes, same here. But I don't have to go, and I decided to go and have sunflowers this year. So this is good. This rain is good for them.
Perfect. Thank you, Katie.
Yes, thank you so much.
Yes, of course. Thank you guys. Good job, everyone.
Thank you.
Thank you.
Awesome.
Yeah. Bye-bye.
All right. Bye, everyone.
Bye.